Hi guys, Miss Griffin. We're looking at Unit 10, Skill 5, segments within circles. So last time we did angles, this time we're doing segments. And your essential question is here, so go ahead and take a second to copy that down. How can we find the length of segments within circles? So we're going to start with two intersecting chords. And again, I just want to remind you, the more you write this down, the more it's going to stick in your head. A chord connects 2 points on the circle. So this chord, it stays inside the circle. It connects this point to this point, and that's one segment. Then we have a chord connecting this point to this point, and that's another segment. Now point E splits our two segments up into 4 parts in total. So we have like part 1, part 2, part 3, and part 4. So this formula says part times part equals part times part. So what we do is we call it the PP equals PP formula. I know that sounds weird and maybe a little gross, but just go with it, okay? So when we have this, we're really multiplying part 1 times part 2, and it's setting it equal to part 3 times part 4. So again, I just want to reiterate this. These have to be from the same segment. And these have to be from the same segment. All right, so we're going to do this example. They give us AE is 6, BE is x minus 1, CE is 9, and DE is x minus 3. So when I look at this, I'm just going to blow this up some. I have CE, ED, AE, and let me grab another color. Orange will do. BE. So we've got 4 different parts, and I'm going to recall that the formula is PP equals PP. And so what I'm going to do is take my first part, say 9, and multiply it by its matching part on the same segment, x minus 3. So blue and green came from the same segment, they go together. And then we have equals. Then I'm going to take 6 and multiply it by x minus 1, because they are on the same segment, those two parts. So then from here, we just have to solve. So 9x minus 27 by distribution, and 6x minus 6 by distribution. I want to bring x's to one side, so I'll subtract away 6x, and I'll add 27 to move that. Now we have 3x equals 21, and therefore x equals 7. And that's it. So again, part times part equals part times part. You do have to memorize this. Okay? In this next one, we're going to talk about two secants. Recall that secants are lines through the circle 2 times. It crosses over your circle twice. And so for our formula here, it's called whole times outside equals whole times outside. Formula for this, or the little phrase for it, is whoa, whoa. WO equals WO. And the same rule applies that these have to be from the same segment. And again here. Okay, so if we look at this picture, we have a whole secant, so that's the first whole, and it will be multiplied by the part of the secant that is outside of the circle. So this is my O. Then I have this whole, and it will be multiplied by the part that's on the outside of the circle, O. So we've got this problem that came from a Regents exam. It says in circle O, and notice how I'm going to immediately start drawing this because they didn't give us a picture. Secants ADB and AEC are drawn, so I know each one has to cross through the circle twice. And I know that they're going to meet at point A because not only do they say it, but also A is the shared vertex. Sorry, my zooming's going all over the place. Okay, so A is out here, and then we'll go D, B. This can keep extending, but I'm not going to worry too much about it. And then it's A, E, C. Put dots on each one of these points. And it says that D, B, E, and C are on the circle. Cool, got that. So AD is 8, AE is 6, EC is 12 more than BD. So I don't know anything about DB or BD. I'm going to just call it X. And EC is 12 more than that, so I'm going to add 12 to the X for EC. And it says the length of BD is blank. So I'm going to remember that I called it as X. So when we have two secants, this means we're going to use whole outside equals whole outside because we're finding segments, not angles. So I know that my whole is made up of this whole piece here, X and 8. So that's X plus 8. So that's my whole. This is my outside. So I have 8 times X plus 8. And that's equal to the whole here. That's X plus 12 plus 6. But that seems really messy, so I'm going to simplify this to be X plus 8 and 6 make 18. So I'm going to use this whole times this outside, because it's outside the circle, remember. So we have 6 times X plus 18. And from here, it's just like solving the other one. Distribute, distribute. So 8X plus 64 equals 6X plus 18 times 6, which is 108. Combine like terms, get your x's to one side, numbers to another. That brings you down to 2x equals 44. Divide by 2, and that gives you x equals 22. And if I look back, BD is just x, so x and BD are 22. Flip it over, and we'll see another type of example. All right, last one, folks. So now we're going to put a secant and a tangent together. And so remember that a tangent is the line that crosses circle one time. All right, so same formula as the last one, whole outside equals whole outside. And remember that these have to be the same segment. And these have to be the same segment. A tangent, though, is special because the entire thing is outside the circle, if you think about it. So here's my tangent, AE. And this is a whole piece, because that's all that's there. And it's also the outside piece. So it'll just get multiplied by itself. And then we've got whole and outside. All right. So Regent's problem right here, even though it doesn't look like one we just typed it out. It says we've got circle O with a secant and a tangent. And they meet at R. So tangent touches once, secant touches twice. So this should be ST and then Q. RQ is 12. RT is 10 more than RS. So here's RT, here's RS. We know nothing about that, but this we can call as X plus 10. And our goal is to find the length of RS, which is just X. All right, so we're going to first apply our formula. And that's going to be whole times outside equals whole times outside. So here's my whole, and there's also my outside for the tangent. Remember, tangents are special. 12 times 12 equals the whole times the outside. So X times X plus 10. All right, so here we go with the fun stuff. 144 equals x squared plus 10x, just by distributing. Now, this is called a quadratic equation because there's an x squared in it. So you're going to have to recall the steps from solving a quadratic from back in algebra. So I'm going to list the steps off to the side, and I want you to do the same. First, you're going to get the equation equal to 0. Bring all terms to one side. Then you're going to have to factor. And you might recall your teacher saying you should do add, multiply. And we'll talk about what that means in a second. Third, you're going to solve each factor for x by setting the factor equal to 0. After that, you'll reject any negatives because we can't have negative length. Okay, so I've got to follow through with my first step. I got to get that 144 away so that it's equal to 0. So we have x squared plus 10x minus 144. Now this is not all too common to come up on the exam. It's only come up like twice, factoring. But we do have to know how to do it. So now we're doing this add multiply thing. So I want to think of numbers that multiply to 144 that also add to 10. So I'm going to make a little list off to the side. I've got 144. I know that 1 and 144 make that. 2 and 72. If I do 144 divided by 3, I get 48. Let's see, divided by 4, 36. If I divide by 6, we get 24. 7, 8 is 18. So again, I'm just doing this all in my calculator. 9, 10, nope. We could do 9. 144 divided by 9 is 16. All right, so let's see if any of these pairs would help us add to 10. One of them is sticking out right away, right? 8 and 18. So I put x here, I put 8 here, x here, 18 here. I could do the 8 and 18 in different places. Doesn't matter. But I know that I have to add to a positive, multiply to a negative. So my signs have to be opposites. And the bigger number, meaning this 18, will take whatever sign was for our add term. So that was a positive, this one gets the negative. And it's still equal to 0. Because I know that 18 plus a negative 8 is 10. Okay? From here, I do what's called the T-chart, so that I can set each factor equal to 0. And then I just simply solve. Add 8, add 8. So x equals 8 minus 18 minus 18. X equals negative 18. And then last and final step is to reject any negatives, because remember we're talking about the length of a segment, and so I want to reject this. So I'm going to keep this and say that RS equals 8. Okay? So there's only 2 formulas for you to memorize here. Remember that we've got part times part for this type of picture. Part times part equals part times part. And for this type of picture, you have whole times outside equals whole times outside. Okay? Go ahead and move on to your practice. This is your last and final skill, friends. How exciting is that? You've made it through the whole year of geometry up until this point. Woohoo! You're done. Go celebrate by practicing. How fun does that sound? All right, adios.